Hi, and welcome to 2.6a Kinematic Equations 1. In the next few lessons, we're going to be introducing a few new equations. So I broke it up into 3 different lessons. This is the first of those 3. In all of these lessons, students will be able to use kinematic equations to calculate the physical quantities associated with and fully describe the motion of objects. So the physical quantities that we're talking about displacement, velocity, acceleration, even time. We're going to have a bunch of different equations that include the initial velocity and the final velocity. So that's what we're talking about there. So deriving an equation. Deriving an equation means taking something you already know and making a useful relationship out of it. For example, if a drag racer is accelerating from rest and I want to find out what its final velocity is, I can rearrange the formula for acceleration to make a handy formula. So this is what we know. And then when you cross multiply, you get VF minus VI is equal to AT. And then if you add VI to both sides, you get a handy formula that would tell you the final velocity if you knew the initial velocity, the acceleration, and the time. So you could just use this equation anytime you need to find the final velocity. This equation is located on your reference table on the back page right here. So we're working our way down. We did the average velocity, and then we did the acceleration, which is VF minus VI over T. And now we have this rearranged formula for that one. And as you can see, we're going to go down the line. So all of these equations are considered the kinematic equations. These two we did when we did vector stuff, and then we get into dynamics. So that first equation, it wasn't anything fancy. We just rearranged one equation. But we can also combine equations to make new useful equations. For example, now we want to know how far the drag racer travels. We know the initial and final velocities and how long the race is, the time. All we have to do is ask ourselves one question. What are two equations that we already know for average velocity? So we're going to combine two equations together. What's one equation? Think about it. You might have said the one that's on the reference table. The average velocity is equal to the displacement divided by the time. Now, if you knew the initial and the final velocity, and they said, okay, what is the average velocity? Can you think of another formula that you might use to find the average velocity? Well, if you just add those two numbers together and then divide by 2, that's average. You're finding the average velocity. Okay, so what we're going to do is set these two equations equal to each other and then do some rearranging. So if we know that d over t is equal to the average velocity and vf plus vi over 2 is equal to the average velocity, then it stands to reason that those two equations are equal to each other. And then we can cross multiply and you get vf plus vi times t is equal to 2 times d. And if we wanted to solve for the displacement, we just divide by 2. And then we could divide by 2 like this, but then we'd have d is equal to a weird fraction like this. So instead we write 1/2. So dividing by 2 is the same as multiplying by 1/2, vf plus vi times t. And now we have a handy new formula that we could use to find the displacement if we know the final and the initial velocities and the time. So the question is, where is this on your reference table? Try to find it. Pause the video and look at your reference table. Should be on the back page, right? Or is it? This is the secret formula. It's not on your reference table. You have to write it in. So you got to go to the reference table on the back. It's not located here anywhere, so you're going to have to write it in if you want to remember that d is equal to 1/2 times vf plus vi times t. And remember, it's just the average velocity formula and then the average velocity formula, and then we combine the two. So it says a drag racer starts from rest and reaches a speed of 122 meters per second in 5.5 seconds. How far does the drag racer travel from during this time period? We're going to do the guess method. Now this image takes you to a video in the PowerPoint I put the video in the green extension folder for this lesson. So if you want to check out some cool drag racing, that's totally fine. You could do that in the extension folder. But for right now, let's do some physics. So we're going to do the guess method. The first step is to write down your given information. All right, so it starts from rest. I would underline this. This is hidden information. Starts from rest. What does that tell you? That means the velocity is 0, right? And it's starting from rest. So not just the velocity, but the initial velocity is 0 meters per second. Normally you just look for the numbers, right? Well, that's not, the number isn't there. It's hidden information. It reaches a speed of 122 meters per second, so that's the final velocity in 5.5 seconds, so that's the time. Now it says, how far does the drag racer travel during this time period? So if they're asking for how far, then they're asking for the displacement. Okay, then once you know your givens and your unknown, you have to look in your reference table for an equation that has those givens and the unknown. As we do more and more, I'm going to introduce more and more equations in the next couple lessons. So it can get a little confusing. My pro tip is to get familiar with the variables that you're looking for. The one that's not listed here is the acceleration. So any equation that has acceleration in it, we don't want it because we don't know what that is, and they're not asking for it. So if acceleration is in the equation, that's going to give us 2 unknowns instead of just 1. So sometimes it's helpful to look for the thing that you don't want. So once you determine which equation you want to use, and in this case we'll use d is equal to 1/2 vf plus vi times t, then you can substitute in your numbers. So we're looking for the displacement, 1/2 of 122 plus 0 times 5.5, and then you can solve. So you get 335.5 meters. So for these, I want you to do the guess method. Write down your givens, write down your unknown, write down your equation, then substitute, then solve. All of the equation, all of the steps of the guess method I want to see on your paper for tonight's practice assignment. So let's clear up a misconception some people have. So d equals 1/2 vf plus vi times t. Does that mean we can only use this formula to find distance because they're saying, oh, the distance is equal to this stuff, and this is only useful if you're looking for the distance? What do you think? Can we use this equation to solve for vf? Yes, because you could plug in a number here and then just solve for vf. Can we use it to solve for vi? Yep. Can we use it to solve for t? Yes. It's really more about, oh, I have these and I'm looking for one of them, and the acceleration is not involved at all. So if you have the acceleration or if you're looking for the acceleration, you're not going to use this formula. But if you don't care about the acceleration and you have the 4 other physical quantities here, then you can definitely use it. So do this practice problem on your own, and then I'll write the solution here. So pause the video, try it out, and then I will write the solution. So it says you're getting off 287 at exit 8E. You want to slow down, so you step on your brakes for 5 seconds, reaching a new speed of 15 meters per second. You cover 100 meters of ground during this deceleration. What was your initial velocity? So here are the givens. The unknown is VI. And as you can see here, we don't have the acceleration. They're not looking for the acceleration, so we can use that secret formula. And at this point, you can substitute in your values and then solve. And you get an initial velocity of 25 meters per second, which makes sense. So we started at 25 and then we ended up at 15 because we're slowing down. Our acceleration would be negative if we solved for it, but they didn't ask for the acceleration. Or a different possibility would be to, since you're looking for VI, solve for VI in your equation first and then plug in. So I'll just show that real quick. So now it's almost like we derived another equation for VI, and at this point it might be easier for you to just substitute in the values and solve. And you still get VI is equal to 25 meters per second. So it's really personal preference. Typically, I will start with the equation and then substitute in the values and then solve. But I know some people definitely like to solve for the variable first so that they don't have all these messy numbers flying around in the equation. You just plug it into one side and then evaluate, and you could even plug it in your calculator if you're careful about your parentheses and just do it all in one step. Like I said, personal preference, but it's totally up to you. Both valid ways to do it. I just wanted to say one thing about the practice. If you're going to submit this for a assignment grade, make sure you read the instructions. I want you to show all work using the guess method and make sure you substitute with units. Do all of these homeworks, the next 3 homeworks, really all the homeworks, but especially these next 3. I want you to practice writing the given information on the side, writing the unknown information with a question mark, because I'm telling you, it helps people determine which equation to use. It's not just because I want you to waste your time. Like I said in the beginning of this video, we're going to be introducing a lot of different equations in the next few lessons, and it could get overwhelming with how many different options there are for the equation. So if you try to just jump to the equation one, you might find that it's kind of difficult. So it should become second nature to write the given and unknown information down first with the units. That way you don't have to worry about getting units, points off for units on your test. Just do that right in the beginning. And then, like I said, it'll help you figure out which equation you're going to use. Um, maybe not on this one because we only added a couple more equations. But if you get into the habit of doing the process, the next homework and the next homework after that will be that much easier. I don't like to say easier, but you'll have the method down. Okay. That's about it. Thanks for watching and have a great day.